Hello, Assalamu alaikum, and very good afternoon to my respected teacher, Jewel sir, and to my all classmates. I am Nisha Tanjum, ID 19115123132. Today, my presentation topic is linear search. Hope you will enjoy it. So let's start. So firstly, we have to know that what is linear search. Linear search is a very simple searching technique which sequentially check each and every elements of a list until it found the element that we are searching for or the whole list has been searched. That means if I have a list of some elements like pen, pencil and paper and I wanted to search a specific element, then it will start searching from the first element and will check every element of the list one by one. If it find out this element in this list, then searching will stop. But if it didn't find the element, then it will search the whole list and lastly will say don't found. So it's a sequential search. Then let's talk about the advantage and disadvantage of linear search. Linear search is simple searching technique or it's follow the simple searching algorithm. So it's very easy to understand and implement. Then for linear search, the list does not need to be sorted. It works in sorted list and also in unsorted list. Then it's not affected by the insertion and deletion, and it performs quite fast for small to medium sized list. That means if I have a small or medium sized list, then it will perform quite fast. Now the disadvantage of linear search. Firstly, linear search is very slow searching technique for a large list. For example, if I am searching through a database of everyone in Dhaka city to find a particular name, it might be necessary to search through 8 million names before I found the one that I wanted. So it's required lots of time. Then the performance of the algorithm scales linearly with the size of input, and it has very poor efficiency to find a particular record in big files. Now let's talk about the working procedure. For example, I have a list of 5 elements which is 10, 20, 40, 30 and 50. And I have to search for 30. So now I will start checking from the first element. My first element is 10, so it didn't match, so it will go to the next element. In the second position here is 20, so it also didn't match. In the third position here is 40, so it also didn't match. And finally in the fourth location here is 30, which is match. So where I found the 30, I found at fourth location. Now and here the searching will stop. But if I'm searching for 60, then it will follow the same procedure, and when it will come to the fourth position, and it will see that in the fourth position here is 30 and I'm searching for 60, so it will not match. Then it will go to the next element, and which is fifth location. Here is 50, so it also didn't match. So it will search from the start to end, and the search is complete, but the element is not found. Now let's see the algorithm of linear search. Here L is the array of data item and N is the total number of item in array list, and key is the item to be searched. So firstly I have to set the array index k equal 1 and location equal 0. I can also set the array index equal 0. Then I will repeat step 3 and 4 while k is less than or equal n. If I think about my previous example, then there was 5 elements. So for that I have to repeat step 3 and 4 while k is less than or equal 5. Then what is the third step? In third step, it will check that the number I am searching is matched with the data in the array or didn't match. If it match, then it will set the location to the index where the data was and will exit. If it didn't match, then the increment of the array index will happen. And after that, if I didn't found the element that I want to search, then the location will be 0, and if location is 0, then it will print that not found and will exit. Now let's see the time and space complexity of linear search. If the element I am searching present at last position, then I have to search all elements. So it's the worst case. So for that my time complexity is big O of n. For average case it's say big O of n, and if I found the element at the first position, then my it's the best case. So for that my time complexity is big O of 1 or big omega of 1, and the space complexity of linear search is big O of 1. So that's all from me. Thank you.